using old cathode ray tubes. This subject comes up regularly when we're demonstrating radar room equipment at 1940s events. To some, is it worth keeping is often the question, whereas to others, it's a case of either how easy is it to use or what can I make with it? In reality, a small cathode ray tube on its own makes an interesting conversation piece, though to actually make it work is another question altogether. All cathode ray tubes, or CRTs for short, need a high voltage to make them function. While some require a lot lower potential than others, we're still talking about plus or minus several hundred volts with which to technically electrocute yourself with. Even with a small tube, there are essentially two distinct types that might help make the decision of whether or not it's worth trying to make it work. This distinction is the deflection method used in the tube itself. Electrostatic deflection will move the electron beam around on the fluorescent faceplate, whereas magnetic deflection will need a set of compatible deflection coils to start things off. Whilst putting voltages on the deflection plates is relatively easy, deflection coils limit the usage of the tube, as you can't simply put voltages on the coil and expect it to use in a similar manner. Without referring to the part number on the tube, it's easy to identify which type of tube it is by the width of the neck. A thin neck implies magnetic deflection, whereas a tube with electrostatic deflection needs a much wider neck to incorporate two sets of deflection plates, or the X and Y plates as we can call them. Quickly going back to the question of part number on a tube, sometimes it'll be easily visible, whereas on occasions it's been worn off and is no longer there. In the latter case, even an expert eye might not be able to work out what it is, as there are several series of CRT in the past which are made in almost identical housings, each with different pinouts and parameters. Take for example these identical looking tubes with DG numbering on them. Back in 2024, the radar room was kindly donated 3 6-inch X radar tubes. This stage not knowing whether any of them worked. It was necessary to look up the part number, ACR13, that was partly visible on just one of the metal shields. Fortunately, the tubes had the same base pinout as the tube in our test set 43, so a quick swap was arranged to test all 3 of them. Turned out that all 3 worked, but 2 had a strange internal defect on the tube face in the same location. Whilst this limited any serious usage in some areas, it certainly didn't stop them used for potential projects. Straight away I came up with the plan for a kind of CRT educational demonstrator exhibit for our display, although at the time it seemed an awful lot of trouble to go through for just an occasionally used device. Therefore decided to expand the project to incorporate a fully functional oscilloscope in the same housing at the same time. The scope controls being hidden by a removable panel to cover the controls when it's being used as a demo device. Now we come to the interesting part, valve or transistor working. As the tube itself has a high voltage, a source for high voltage will be needed anyway, so why preclude valves? However, in order to avoid any complex switching, the microprocessor test demo unit ideally needed a second set of X and Y plate driver devices in order to keep setting the demo unit each time the scope controls are hidden under the front panel blanking plate. Hence the whole unit turned out to be a hybrid, with 4 valves for the oscilloscope functions and transistors being used for the demo circuit with the microprocessor. The micro, with all of its semiconductor devices being housed in a small box along with a few LEDs, push buttons, rotary pot and a 24-digit LCD display. This unit is designed to be plugged into the front panel of the main unit, using a multi-way Jones plug. Bear in mind that this had some high voltages on it, obviously to drive the plates. It's a bit of a squeeze, but yes, it all fits neatly into the small wooden box. So back to the cathode ray tubes, one must remember that many old CRTs are nowhere near as good as later versions. This is borne out by 3 ACR13s. Ignoring the screen defect for the moment, look how the sine wave is distorted at the very top and bottom of the screen when the Y shift control is rotated. This is not a fault, this is just what the tube is like. Likewise, the actual spot is not that easy to turn into a spot. Not exactly an issue with the intended usage, of course. It's just worth pointing out that most newer CRTs from the 1950s produce a much superior display, even when the tube has been well used. So back to the high voltage requirement, many cathode ray tubes specify a maximum figure of several thousand volts to produce a good display. In reality, this figure can generally be reduced considerably, yet still allowing for a good bright image on the tube faceplate. Interestingly, I'm using a significantly lower voltage on the tube within this demo unit when compared to the test set 43 they originally tested on. And you can probably see that in this video they are much darker on the new unit. So lastly, let's talk about what you can actually do with an old cathode ray tube. Clearly, a useful oscilloscope is one of the most obvious applications. I'd personally like to say that using one to generate a computer-type display to show small text is something I'd personally never try with an older style tube, particularly like these ACR13s. Driving a simple display, even with a mere half a dozen lines text for a micro, this is actually quite difficult. And for anybody determined to look into this, I might be tempted to show just how to do this in a future video, though I just said it isn't easy. As this unit's a long way from being completed, all I can do now is show what it's currently capable of, first as an oscilloscope, and then going on to totally transistorized deflection drivers and what you can do with a micro. As you can probably see, the unit works quite well as an oscilloscope, though the HF performance is a bit limiting. Possibly quite useful for after-hours fault finding at a weekend event, I'd imagine. Must remember to pack that scope probe. Certainly as far as the actual demo bit we're using the microprocessor is concerned, I'm currently compiling a varied and interesting list of program steps to write, demonstrating how a CRT works. Several of these planned steps use the rotary pot on the user operating control box to make the display change. And my experience at live events finding that people do like pressing buttons and twiddling knobs, even the ones they're not meant to. So that's about it. Hopefully you found this an interesting hybrid project, showing how we can incorporate both transistors and valves into a base unit containing an older style CRT. Thanks for watching.